Welcome to our math class today. Today we're going to focus on the substrand concepts from the strand 1 of the curriculum for year 15, which is numbers. Our learning outcomes today, we are to learn how to identify and define what a search is. We are to learn how to apply the 4 operations which are addition, subtraction, multiplication, and division to simplify search expression. We also have to learn how to expand search expression to the power of 2. Those are our learning outcomes for this substrand for mathematics. Our keywords today, we will focus on the keywords and concepts: simplify, expression, commutative law, associative law, distributive law, order of operation, search, and laws of search. Now, for today, because of the time limit, we are going to focus only on the simplifying up to the order of operation. And in the next lesson, we will focus on the search and the laws of search linking to today's lesson. Now, before we get to the main learning outcome, which is on search and the simplifying on search of search expression, we need to revise some prior knowledge. Let's go on the screen and check out what we have on the screen. The prior knowledge you're supposed to be learning from the lower level, year 12 and even lower, are the basic algebra simplifying of expression, exponent and laws of exponent, and order of operation. As you all know, we call it PEDMAS. Remember, the word exponent is the same word as power or the word integer. We use the word integer sometimes. So some revision of prior knowledge. What does simplifying an expression mean? Why is it important to simplify expression? Simplifying means writing an expression as simply as possible. It is important to simplify to make calculation easier and faster. Now, what is an expression? In math, what is an expression? It is a mathematical statement or sentence with a minimum of 2 terms containing numbers or variables or both connected by an operator. I have here 2 examples. X plus y is an expression. X and y are terms. The addition sign is the operator, and both terms are variables. Coefficient of each term is 1. X and y are unlike terms. These are all the terms, these are all the terminology that you should have learned from lower level. Example number 2, we have 5a minus 10 is an expression. 5a and 10 are terms. The subtraction is the operator. The terms are algebraic terms. The 5a is an algebraic term, and the number 10 is a number or numerical term. The coefficient of a is 5. Remember what the coefficient is? The number before the variable. Okay? 5a and 10 are unlike terms. Now, let's go back to our memory lane and find out again what are like terms and unlike terms. Like terms have same variables and same powers or same exponent. Remember, variables can be a letter, it can be a simple replacing the number. An example, a and 2a are like terms. Why? Because a and a are the same variable, and both of them have the same power of 1. Another example, a squared and 2a squared are like terms, because a squared and a squared have same power, same variable. Okay? Unlike terms may have same variables but different powers or exponent, or they may have different variables but same powers. For example, a square and 2a cubed are unlike terms. Why? Because a square and a cubed have different powers, although they have the same variable a. X and y, as in our previous example, are unlike terms because exactly y exactly x. This is the same concept that we apply when we say, what is an apple plus a banana? Then the answer is still an apple and a banana because you can't say apple banana because there is no such thing as apple banana. Okay, so that's an application of these concepts. Let's have a look at some basic mathematical laws. Okay, we have some basic mathematical laws called commutative law. The commutative laws say, in addition, a plus b is the same as b plus a. For example, 2 plus 3 is the same as 3 plus 2 because they both add up to 5, right? In multiplication, the commutative law, a times b is the same as b times a. For example, 2 times 3 is the same as 3 times 2. They both equal 6. The other law for the mathematics, basic mathematical law, is called associative law. The associative law states that for addition, a plus bracket b plus c bracket is the same as a bracket a plus b bracket plus c. For example, if you have 2 plus bracket 3 plus 4 bracket, it's the same as bracket 2 plus 3 bracket plus 4 because both sizes add up to 9, right? Remember the order of operation? You do the bracket first, that's 7. 3 plus 4 is 7, and then you add the 2, it's gonna be 9. And on the other side, you add 2 plus 3 is 5, 5 plus 4 is 9. Okay? So that's the associative law for addition. Associative law for multiplication, similar to the addition, you have a times bracket b plus c multiplied by c bracket is equal to bracket a times b bracket times c. So it's a simple example there. 2 times bracket 3 times 4 is the same as 2 times 3 bracket times 4 because both sizes would be equal to 14, right? 3 times 4 is 12. Not 14. 3 times 4 is 12. Times 2 is 24. And the other side, 2 times 3 is 6. Times 4 is also 24. Okay? The last basic mathematical law is called distributive law. Distributive law, this is when you have multiplication and addition in the equation. For example, a times bracket b plus c bracket is the same as a multiplied by b plus a multiplied by c. This is the law we will later use in algebra to do expansion. So remember this. Example, 2 times 3 plus 4 bracket is the same as 2 times 3 plus 2 times 4. Why? Because they will have the same answer. The left hand side you're going to have 2 times 7. 2 times 7 is going to be 14. On the other side you will have 2 times 3 is 6 plus 2 times 4 which is 8. 8 and 14 is, and 6 is going to be 14. So both sides have the same answer. Alright, so let's revise our order of operation. This is something that you should already have learned from, even from primary level, the order of operations. We have a mnemonic and we call it the BEDMAS. B stands for bracket, E stands for exponent or power, D stands for division, M for multiplication, A for addition, S for subtraction. Now, I have the bracket there next to division and multiplication, and another bracket next to addition and subtraction. Why? Because the order of operation say that you can do division if it's a pair first, or you can do multiplication if it's a pair first in the order of the equation. Same thing with addition and subtraction. Mua mai le whakateko ese, whai mua ko ese. Ka whai le whakapopo. You do addition first if it's a pair first. You do subtraction first if it's a pair first in the equation. Simple example we have there, 2 plus 3 bracket multiplied by 4 times 5 bracket. Now, according to the order of operation, we do the bracket first. So 4 times 5 is 20. And then we do the multiplication, which is 3 times 20, and that's 60. And then you finally add the 2, and the answer is 62. Right? Very simple if you remember the order of operation. Some very important laws in mathematics are the laws of exponent, because when you study algebra, you will be studying a lot of equations with power more than 1. So the law of exponent enable us to simplify the equations, algebraic equations, so that we can solve a word problem and so forth. So let's have a look at the first law of exponent. First law of exponent is called products of powers. We say that a to the power of m multiplied by a to the power of n is the same as a to the power of m plus n. Now you are adding the powers. And the proof, let's have the proof. Normally when you are always telling, you are always being told all these laws, but we want to know, how did this law come? Where did they come from? Okay, so let's have a proof. Have a look at a to the power of 2 multiplied by a to the power of 3. According to the law of exponent and products of power, is going to be equal to a to the power of 2 plus 3, which is equal to a to the power of 5. Now, where did that come from? Let's have a look at it. When we have power, it means you are multiplying, okay? So if you have a power of 2, it means you are multiplying the a 2 times. If you have a power of 3, you are multiplying the a 3 times. So if you have a look at the bottom, you have a times a, which is the a to the power of 2, and then continue the multiplication with a to the power of 3, you have 3 more a's. Yeah. So lima a never kill it. The a is being multiplied 5 times. So that's why you have a to the power of 5. You get that? Alright. Move on. Second law of exponent is called power to a power. That's when you have in the bracket a to the power of m, outside the bracket is a power of m. And according to this law, it is the same as a to the power of mn. Now we know, if I kill the power m and n, they do it. You are multiplying m and n to give you the power of a. Let's have a proof. For example, if we have a to the power of 2 inside the bracket, multiply the power like for is 3, then according to this law is the same as a to the power of 2 times 3. And that means you have a to the power of 6 because 2 times 3 is 6. Now, where did this come from? Again, the power, the exponent means you is the number of times you are multiplying the term. So the power of 3 outside the bracket means you are going to multiply a to the power of 2 3 times. A times a to the power of 2 times a to the power of 2 times a to the power of 2. So you add all those two. Remember the law the powers of a power. When you are multiplying, you add the power. So you add 2 plus 2 plus 2, and that's right to a to the power of 6. Alright? So let's move on to another law of exponent. Remember the products of a power? Products of a power. Now this law states that if you have a times b inside the bracket and there is a power of m outside the bracket, then it's the same as a to the power of m, b to the power of m. Now, inga the power outside the bracket, or power I, a koi power I for the b. And this is something similar to the distributive law that we were talking about earlier on. Okay, so a proof ab to the power of 2 is the same as a to the power of 2 multiplied by b to the power of 2. Where this comes from? ab to the power of 2 means you are multiplying ab 2 times. ab times ab. If you break it down any further, it means a times a, b times b. Okay? So you end up with 2a to the power of 2, 2a being multiplied. That means you have a squared, or a to the power of 2, and b to the power of 2 as the final answer. Okay? Moving on to another law of exponent, we have quotient of powers. Just like we had products of power, we have quotient of powers, because sometimes expression it comes in fraction, right? So if you have a fraction with a to the power of m divided by a to the power of m, the quotient of power law say you can simplify it down as a to the power of m minus n. Right? Nung inga ko, esse may le power lay lalo. Ile denominator. May le power lay nung numerator. Let's have a look at the proof. A to the power of 3 divided by a to the power of 2. According to this law, it means a to the power of 3 minus 2. 3 minus 2 is 1. And that means you have a to the power of 1. And normally in mathematics, when you have a power of 1, you don't write the 1. Okay? You just write down a. So, where this law comes from, let's have a look. A to the power of 3 means you are multiplying a 3 times, a times a times a, on top of the numerator. And in the bottom, you have a to the power of 2, which means you are multiplying a 2 times, a times a. Now remember the basic mathematics, you can cancel like terms, because they are all like terms. Cancel esse lola e lesi lua. Cross out the 2 on the top, cross out the 2 at the bottom, and that leaves you only one a. So that's where this quotient of powers is coming. Let's have a look at our next law of exponent. It's called power of a quotient, just like we did for multiplication. So if you have a fraction a over b, and outside the bracket is a power m, it's the same as having a to the power of m divided by b to the power of m. Now, ingat power uma ile a ma le b, ile same power le for the bracket. For example, or the proof, a over b to the power of 2 is the same as a to the power of 2 divided by b to the power of 2. Where did this come from? A over b bracket power of 2 means you are multiplying a divided over b twice. That means you have on the top a multiplied by a, and denominator you have b times b. And you know from your basic mathematics and multiplication, a times a is a squared, b times b is b squared. Moving on to our next law of exponent is zero power. Remember, you always see this. They always say a to the power of 0 or anything to the power of 0 is equal to 1. That's provided a is not equal to 0. Okay? So if a is not equal to 0, you can say a to the power of 0 is equal to 1. So anything to the power of 0 is equal to 1. By the proof? The proof comes from the law of quotient of power. A to the power of 0 is the same as a to the power of n minus n. Because to get 0, you are subtracting the same power. N minus n means 0. Alright? And remember from the law of quotient of power, it means you have a to the power of n divided by a to the power of n. And then both the numerator and the denominator are the same, so that means you cancel them out and you get 1. And a to the power of n divided by a to the power of n is equal to 1. Moving on, we have another law called negative power. Right? I'm leading you here to the series. Okay? So bear with me. We are going to almost get there. So the negative power, they say if you have 1 over a to the power of n, it's the same as a to the power of a negative n, provided that a is not equal to 0. A cannot be equal to 0. Why? Because division by 0 is undefined. You cannot divide anything by 0. Okay? So, example, if you have 1 over a to the power of n, and remember that just before this we say that 1 is the same as a to the power of 0. Remember? So, in the quotient law of powers, we can say a to the power of 0 divided by a to the power of n is equal to a to the power of 0 minus n. And 0 minus n means you have a to the power of minus n. And that's where the negative power comes from. Right. Another law of exponent for us to revise is called the fractional power. And we need fractional power is actually expressing the fractional power in search form. Now we are getting closer to the learning outcome of this whole substrand. So they say that if you have a to the power of 1 over n, which is a fraction, you can divide it as a series as the nth root of a. Nth root of a. Okay? So remember from basic mathematics, you have learned how to calculate the cubic root, the square root. So the square root of a is the same as a to the power of a half. The cubic root of a, cubic root of a is the same as a to the power of 1/3 or 1/3. Now, we are moving to our search, which is the main learning outcome of your level strand number 1. The power of a search. Now, if you have a to the power of m divided by n, you can rewrite it as a series as the nth root of a to the power of m, or you can rewrite it as the nth root of a all to the power of m. Okay? Bracket all to the power of m. They are the same. Whatever way you rearrange it, you will find that they have the same answer. And that's the proof right there underneath. A to the power of m divided by n is the same as a to the power of 1 over n to the power of m, and you can rewrite it as the nth root of a all to the power of m. Or you can have a to the power of m divided by n is equal to the a power of m and also power to 1 over n. And then you can rewrite it as the nth root of a to the power of m. We will talk some more about series in the next lesson. Okay? I'm just leading you here to that learning outcome by revising our prior knowledge. And that's all the prior knowledge you will need for us to move forward with this strand. Okay, so now that you have learned all those laws, basic operation, order of operation, memorizing them and refreshing our memory from the previous years, we are now going to have some exercises to practice. Okay, so I want you to copy this down, and then you go home and practice using what we have talked about today to simplify using the laws of exponent and the basis law. Okay? Only 6 problems I have here for you to practice at home. So, let's sum up. What have we learned today? We have learned today what an expression is, what simplifying an expression is, what like terms and unlike terms are, what commutative, associative, and distributive laws are. We have refreshed our memory on the order of operation and bedmass from previous years, and we have also looked in depth to the laws of exponent. Now, 3 main ideas I want you to take away from today's revision on laws of exponents are: when the exponent is positive, it tells you how many times you need to multiply a term or a variable. Note the connection here: positive exponent, multiplication. Okay? The second idea I want you to take away from today's lesson is this: negative exponent means divide. Okay? Associate negative exponent with division, because division is the opposite of multiplication. So positive exponent, multiplication. Negative exponent, division. Okay? You get the connection? And the last main idea for you to take away from today's lesson is fractional exponent. Fractional exponents mean you are taking the nth root of the variable. Okay, so you associate the fractional exponent with the nth root, like the square root, the cubic root, the fourth root, or even the 10th root. And you can even say fractional exponent is another way of expressing search. Remember, we are supposed to be studying search as our first and we are going to get there in the next lesson. So the next lesson we will use all that we have learned today, our revision today, and then we will apply it to simplify and expand search expression. That will be our next lesson. Until then, so far.